Hello friends, welcome to Learner's Planet. This is Alka. Friends, in this session we will discuss about the divisibility test. Now, what does the term divisibility mean? Friends, sometimes we have to check whether a given number is divisible by some other particular number or not. This can be done if we divide the number by that particular number and see if the remainder is 0 or not. If remainder is 0, then the number is divisible by that particular number, and if it is not 0, then the number is not divisible by that particular number. The method becomes somewhat lengthy. So if we follow some rules, we can come to know whether the given number is divisible by that particular number or not. Suppose we have to check here in this, let's take one example. Here it is B, that is divisor, that's dividend, and A is the divisor. Okay. Now we have to check whether B is divisible by A or not. We divide B by A, and if we get the remainder as 0, then B is divisible by A. If we don't get the remainder as 0, then B is not divisible by A. Okay, so let's discuss some divisibility test. Now, in the very first case, we see the divisibility test of 2. A number is divisible by 2 if the digit at the units place is divisible by 2. In other words, we can say the unit digit of the number should be 0, 2, 4, 6 or 8. That means if a number is having 0, 2, 4, 6 or 8, it will be divisible by 2. Let's take some examples. Here we are having 234. Since 234 is having 4 at the units place, hence it is an even number, so it will be divisible by 2. Similarly, 445, it is having 5 at the units place, which is not an even number, so it won't be divisible by 2. Similarly, in this case, the units place, at the units place, number 5 is there, which is actually an odd number, so it won't be divisible by 2. In this case, 54320, we are having 0 at the units place, so it will be divisible by 2. In this case, we are having 6 at the units place, so it will be divisible by 2. And in this case, 65231, we are having 1 at the units place, which is not an even number, it's actually an odd number, so it won't be divisible by 2. Now let's see the divisibility test of 3. If a number will be divisible by 3, a number will be divisible by 3 if the sum of digits of the number is divisible by 3. Let's elaborate it with some examples. I am having a number 456 over here, and according to the rule, I try to add the numbers. So it's 4 plus 5 plus 6. What I am getting over here is 9 plus 6, 15, and one more time I will add the digits, that is I'll be getting 6, that is 1 plus 5. So 6 is divisible by 3, hence the number 456 will be divisible by 3. Similarly, in this case, 7 plus 8 plus 9 plus 2. We can even shorten the method by taking off the numbers which are already divisible by 3. Here 9 we should not add. It's not necessary to add. If at all we add, then also it doesn't make much difference. But since 9 is already divisible by 3, it's not necessary to take this into the calculation. Similarly, 7 plus 2, 9. Further it is divisible by 3. So we left with 8. So 8 is not divisible by 3. Hence 7892 will not be divisible by 3. Similarly, in the example 74321, 74321, 2, 1. 3 is divisible by 3. This 2 plus 1 is divisible by 3. So we left with 7 plus 4. That will give us 11. And 11 is not divisible by 3. So 7, 4, 3, 2, 1 will not be divisible by 3. In the next case, 6, 5, 0, 8, 1, 2. 6, 5, 0, 8, 1, 2. 6 is divisible by 3. 2 plus 1, it is divisible by 3. We left with 8 plus 5, that is 13. So 13 is not divisible by 3. So 6, 5, 0, 8, 1, 2 will not be divisible by 3. Let's take this example. 3, 4, 5, 6, 7, 8. 3, 4, 5, 6, 7, 8. 3 is divisible, 6 is divisible. 4 plus 5, that is 9, which is also divisible. So we left with 7 plus 8, that is 15. So 15 is divisible by 3, hence 3, 4, 5, 6, 8, this number will be divisible by 3. In this case, 2, 6, 3, 4, 3, 6. 6 is divisible by 3, 3 is divisible by 3, 3 is divisible by 3, 6 is divisible by 3. And we are left with 2 plus 4. So it is further 6. So it is divisible by 3. The complete number is divisible by 3. So I hope you must be cleared about the divisibility test of 3. So doesn't matter if the number is very big, you can eliminate the numbers which are already divisible by 3, and you can eliminate even the sum in which we are getting the number is divisible by 3. Let's take a random example. 2, 3, 1, 4, 5, 6, 2, 7. Okay. Now in this case, 2 plus 7, it is divisible by 9. 4 plus 5, it is divisible by, 2 plus 7, it is divisible by 3. 4 plus 5, it is divisible by 3. 6 is divisible by 3. This 3 is divisible by 3. And the remaining number 2 and 1, that is 2 plus 1. It is also divisible by 3. So this complete number is divisible by 3. Now let's see the divisibility test of 4. A number will be divisible by 4 if the last two digits of the number together are divisible by 4. So let's begin with the first example. In this case, 5432, the last two digits are 32. Now 32 is divisible by 4, hence the complete number will be divisible by 4. Similarly, in this case, 7890, 90, it is not divisible by 4. 90 is not divisible by 4, hence 7890 will not be divisible by 4. In this case, it's already an odd number, so it cannot be divisible by 4, so do not discuss much about it. In this case, 48 is divisible by 4, so the complete number will be divisible by 4. Whatever may be the size of the number, that doesn't matter at all. We just have to concentrate upon the last two digits. Okay, whether the number is having 5 digits, maybe 6 digits, maybe 10 digits, or maybe 100 digits. You have to concentrate upon the last two digits. In this case, we are having two zeros. That means the number is multiple of 100, and 100 is divisible by 4. Hence, this complete number will be divisible by 4. Okay. Now, in this case, 54. 54 is not divisible by 4. So, 87654 will not be divisible by 4. Similarly, in this case, 78 is not divisible by 4. So 1, 2, 3, 4, 5, 6, 7, 8. This number won't be divisible by 4. Let's take one challenging example which used to come in some good entrance examinations. Here we have been given a counting from 23, 24, 25, 26, 27, and the counting is going up to 38. We have to check whether this number is divisible by 4 or not. So it's a very big number, and it creates a fear in the student's mind ki how could we divide this number by 4 to check. Now, as we have already discussed, we just have to concentrate upon the last two digits. See how big the number is, that doesn't matter at all. What our criteria is the last two digits. Here these are 38. This is 38. So 38, it is not divisible by 4. So the entire number will not be divisible by 4. We don't have to calculate anything, and no worries about it, students. It's very simple. It looks like tedious, but actually it is very simple. Now let's see the divisibility test of 5. A number will be divisible by 5 if the digit at the unit place is either 0 or 5. It is but obvious. We know this rule already. So here let's discuss some of the cases. Here we are having 5 at the units place, hence this number is divisible by 5. In this case we are having 0. So still again this number is also divisible by 5. In this case we are having 8 at the units place. So it won't be divisible by 5, and even in this case we are having 3 at the units place, so even it won't be divisible by 5. Now let's discuss the divisibility test of 6. A number will be divisible by 6 if the digit at the unit place of the number is divisible by 2 and the sum of all the digits of the number is divisible by 3. In other words, we can say a number will be divisible by 6 if it is an even number and it is divisible by 3. We have already discussed the divisibility test of 2 and 3 both as well. So just for a quick recap, I just take one or two examples. Suppose I am having a number 432. It's an even number, so it will be divisible by 2. Now let's check whether this number is divisible by 3 or not. So it's let's try the problem. 3 is divisible by 3. Now we are left with 4 and 2. So 4 plus 2, 6. So it is divisible by 3. So 432 is divisible by 3 and 2 both as well. Hence it is divisible by 6. Divisible by 6. So similarly we can take more examples. 2, 3, 4, 5, 1. Now in this example, this is the first example, this is the second example. In this example we see that the number is not even. So we don't have to calculate it for 3. Since the number is not even, it is not divisible by 2, so it cannot be divisible by 6. Let's take more examples. Let's take a bigger number. It's 35382. Now let's check whether this number is divisible by 6 or not. First let's try for 2. It is divisible by 2 or not. Since the unit at the units place we are getting an even number, so the number is divisible by 2. Now let's check for 3. So it's 35382. 3 is divisible by 3. This 3 is also divisible by 3. Now 5 plus 8, that is 13, and plus 2, 15. So 15 is also divisible by 3. So hence the number, complete number 35382 is an even number as well as divisible by 3. So it will be divisible by 6. Okay. Let's take one more example to check whether the given number is divisible by 6 or not. Just take a random number. 7, 2, 5, 4, 3, 6, 9, 1, 2. Okay. Now this number is even, so it will be divisible by 2. Now let's begin for the to check with the case of 3. So 7 plus 2, 9. It will be divisible by 3. 5 plus 4 is 9, divisible by 3. 3 plus 6 is 9, still divisible by 3, and 9 will be divisible by 3, and 1 plus 2, that is also divisible by 3. So hence the complete number is divisible by 3, and since it was an even number, so the number is divisible by 3 and 2 both as well. Hence it is divisible by 6. Okay, I hope you must be cleared about the divisibility test of 6. Now let's see the divisibility test of 7. Let's see what does it say. In this case we have to make two sets of 3 numbers, starts from unit digit, then add the alternate sets and find out the mutual difference. If it is 0 or any multiple of 7, then the given number is divisible by 7. And we have to be careful that we should not apply the divisibility test for less than 4 digits, because in that case the direct division will be faster than to apply the test. To elaborate this method, let's take some examples. Okay, in this case, we are having a number 1, 2, 3, 4, 5, 6, 7. As we have already seen in the explanation, we have to make the sets of 3 start from the units place. So it's one set 567, the other set 234, and a number 1 is left. So we put 2 0 to make it a set of 3. Now we have to add the alternate sets and deduct the remaining sets of 3. Now 567 plus 1 minus 234. We are getting 334. Now 334 we directly divide by 7. Since we know the table of the 7, 7 fours are 28. We left with the 5 and 54. That is not divisible by 7. Hence 334 is not divisible by 7. So the number, complete number 1, 2, 3, 4, 5, 6, 7 will not be divisible by 7. Okay friends, let's take more example. In this case, we are having a number 5676. So start making the groups from the unit digit. It is 676 minus 5, 671. We can directly divide it from 7. 7 nines are 63. We left with 4. 41, which is not divisible by 7. Hence 671 is not divisible by 7. So even 5676 will not be divisible by 7. In this case, 31647. It is 647 minus 31. So we are getting 616. So let's check for 616. 616 divided by 7. 7 8s are 56. Then we left with 56. So 616 is divisible by 7. Hence the complete number 31647 will be divisible by 7. Friends, the same test is applicable for even 11 and 13. In these cases, we have to see the result is divisible by 11 or 13 respectively or not. As here we were checking about the difference with 7. So in the case of 11 and 13, we have to check the difference is divisible by 11 or 13. Okay, let's take more examples for 7. So you'll be getting more confidence to apply the test. Now let's take this example 39823. So it's 823 minus 39. What we will be getting is 13 minus 9. That is in the final calculation we will be getting 784. Now 784, let's check by 7 directly. 7, 1 is 7, 7, 1 is 7, we left with 1, and 1 and 4, 14, 7, 2s are 14. So we are getting 784 is divisible by 7, hence the complete number 39823 will be divisible by 7. Now let's take this number 442,757. Make a group of 3, 757 and 442. Let's check. 757 minus 442. So it's 7 minus 2. It's 5. 5 minus 4 is 1 and 7 minus 4 is 3. So we are getting 315. Now let's check it by 7. 7 4s are 28. 3 35, 7 5s are 35. So we are getting remainder is 0. That means the 315 is divisible by 7, hence this complete number is divisible by 7. So it's so simple friends. Without actual division, you just concluded that the given number 44275 is divisible by 7. Okay friends, let's move to another divisibility test. Now let's see the divisibility test of 8. A number will be divisible by 8 if the last 3 digits altogether is divisible by 8. Let's take some examples. Suppose I am having a number, I just take a random number 1, 2, 3, 7, 8, 2. So here in this case I have to check whether these last 3 digits, that is 782, is divisible by 8 or not. So let's check. 8 9s are 72. We are left with 6. Then 6 2, which is not divisible by 8. That means 782 is not divisible by 8, that means the complete number 1, 2, 3, 7, 8, 2 will not be divisible by 8. Let's take another example. It's 770032. Let's see the last three digits. It is 032. 032, that is divisible by 8, since 32 is divisible by 8. Hence the complete number 770032 will be divisible by 8. Okay friends, so the test is very simple. You can practice as well. Friends, let's take a very big example of the problem of the divisibility test. Here we are having a number. It's a very big number. I have written down the counting from 11 to 28. In the various exam, these sort of questions are asked. Okay, so the question is asked in various forms, like what will be the remainder if the given number, that is this number, is divisible by 8. Okay, so in other ways we are asked whether this number is divisible by 8 or not. So we don't have to worry much about it. If we just look at the size of the number, definitely it is very big, but we are interested in the last three digits. So last three digits over here is 728. Now let's check for 728. So it's 8 9s are 72 and 8 1 is 8. So we are getting the remainder as 0. That means 728 is divisible by 8. Hence the complete number is divisible by 8. Okay. Do not go much upon the size of the number. We are interested in the last three digits. Okay friends. Now let's see the divisibility test of 9. Okay. Now the divisibility test of 9 is a number will be divisible by 9 if sum of all its digits is divisible by 9. The test is quite similar to the test of 3 and the method is also similar to that. In this case, we just have to check whether the sum is divisible by 9 or not. In the previous case, as in case of 3, we were dividing the sum by 3. Okay, let's take one or two examples. Just I take a random number. 4 7 8 2 9 1 3 5. Let's make the combination of 9. So just a moment. So here let's make the combination of 9. So it's 4 plus 5 9. 9 is divisible by 9. 9, this 9 is also divisible by 9. Then this 7 plus 2, this is divisible by 9. Then 8 plus 1, it is also divisible by 9. So we are left with 3 only, which is not divisible by 9. Hence the complete number is not divisible by 9. Let's take more example. Just choose another random number. 2 7 5 4 3 6 2 5 1 8 3. Okay, let's make the combination of 9. It's 9. 2 plus 7, 5 plus 4, 9, 3 plus 6, 9, 2 plus 5, 7. Okay, this is 8 plus 1, 9, and this 5 plus 2, 7, plus 3, 10. So we are getting 10, which is not divisible by 9. Hence the complete number is not divisible by 9. Now let's take one more example. Here we get 5, 3, 2, 1, 7, 3, 4. So let's make the combination. 2 plus 7, 9, 5 plus 3, 8 plus 1, 9, and we are left with 3, 4. That is 3 plus 4. So 7 is not divisible by 9, hence the complete number is not divisible by 9. Let's take one more example. Over here, I take a number, any random number, 4, 1, 1, 2, 1, 3, 6. Okay, now 3 plus 6 is divisible by 9. Then 2, 1 plus 2, 3, 4, 5, and 4, 9. So the complete number is divisible by 9. Okay, I hope you are clear. You are clear about the test of 9. Now friends, as far as the divisibility test of 10 is concerned, all of us know very well that the last digit has to be 0. If the last digit of the number is 0, the number is definitely divisible by 10. Now let's see the divisibility test of 11. A number will be divisible by 11 if the difference between the sum of the digits at even places and sum of the digits at the odd places is a multiple of 11. We have been given some examples over here. We just check one by one. We have already discussed the divisibility test of 11 when we were discussing the divisibility test of 7. At that time also I told you that we can make the group of we can make the sets of 3 numbers, and we can add and subtract the alternate sets and get the mutual difference. If that particular difference is divisible by 7 or 11 or 13, the numbers will be divisible by that particular number. So in the case of 11, we are having a 2 divisibility test. Whatever is your conveniency, you can follow the test. Let's take the first example. It's 1298. Let's take the first example. It's 1298. Okay, we are having 2 methods over here. In this method, 2 plus 8, 10, and 9 plus 1, 10. 10 minus 10, 0. So the number 1298 will be divisible by 11. Similarly, in this case, 1221, it's 2 plus 1, 3, it's 2 plus 1, 3. So we are getting the mutual difference as 0. So the number 1221 will also be divisible by 11. Now let's take one more example. I choose a number, say 5016. As we have already discussed about the first divisibility test of 11, let's in this number we try the other divisibility test of 11. Okay, so we try to make the group of 3 for this number. So it is 016 and we'll be getting 005. Now we have to get the mutual difference. So finally we'll be getting 16 minus 5, which is actually 11. So 11 is divisible by 11, hence 5016 will be divisible by 11. Now let's take one more example. It is 86812. We can apply any of the divisibility test. Let's on the same number, let's apply both the divisibility test. In this case, 8 plus 2, 10, plus 8, 18, and 6 plus 1, 7. So 18 minus 7, we are getting 11. So this number is divisible by 11. On the other test, 812 minus 86. It's 812 minus 86 is 12 minus 6. It will be 726. Okay. Now 726, 7 plus 6, 13, minus 2, 11. Okay, so this number will be divisible by 11. We have applied both the tests. You can choose any one of them, or you can practice with both of them as well and apply at your conveniency. Now let's see the divisibility by 12. A number will be divisible by 12 if it is divisible by both 4 and 3. Here 4 and 3 are the factors of 12. 4 and 3 factors are the factors of 12, and these factors are co-prime to each other. Hence, if we have to check up the number is divisible by 12 or not, if we can individually check by 4 and 3 which are co-prime to each other, we'll be sure that the given number is divisible by 12 or not. Let's take one example. 2, 4, 6, 8, 9, 2. Let's take this example. First of all, we are going to apply the divisibility test of 4. So last 2 digits we have to see. Here we are having 92 and 92 is divisible by 4. So the complete number is divisible by 4. Now let's check for the divisibility by 3. Now 2 plus 4, 6, which is divisible by 3. 6 is divisible by 3. This 9 is also divisible by 3. Then we are left with 8 plus 2, that is 10, which is not divisible by 3. Hence the complete number is not divisible by 3. But the number is divisible by 4. But the number is not divisible by 3. So it cannot be divisible by 12. Now let's take one more example. Let's choose a random number. It's 8, 3, 7, 8, 6. Okay. The last two digits, that is 86, it is not divisible by 4. So there is no meaning checking the divisibility of 3. So because if the number is not divisible by 4, it cannot be divisible by 12. So this number is not divisible by 12. Let's take one more example. Let's choose one number, that is 107472. Okay, let's check this number. The last two digits, 72 is divisible by 4. Hence the complete number will be divisible by 4. Now let's check the divisibility of 3. So it's 7 plus 2, 9, which is divisible by 3. 7 plus 4, 11, and 1, 12, which is also divisible by 3. Hence the complete number is divisible by 3 and 4 both as well. So the number 107472 will be definitely divisible by 12. Now let's see the divisibility test of 13. As we have already discussed in the some of the previous cases when we were discussing the divisibility of 11 and 7, we have to make the sets of 3 numbers and then we have to find out the mutual difference. If the difference is divisible by 13, then the complete number will be divisible by 13. If the difference is not divisible by 13, the given number will not be divisible by 13. Okay, to elaborate this method, let's take one or two examples. Let's take the first example. It's just a moment. It's 8, 5, 5, 4. Okay, now we have to make the sets of 3 numbers. So it's just we put 2 zeros over there. Now 5, 5, 4 and 8. So 5, 5, 4 minus 8. Now what 5, 5, 4 minus 8 is? It's 546. Now let's try 546 by 13, as we have already discussed that if the numbers are less than number of digits in a number is less than 4, we should not apply the divisibility test. So let's check 546 by 13. So 13 4s are 52, 2 and 6 26. So 13 2s are 26. So the number 546 is divisible by 13, hence the complete number will be divisible by 13. Let's take one more example. Now we are having a number 2, 5, 6, 4, 7. Okay, we try to make the group of 3. Now 647 minus 25. We will be getting 7 minus 5, 2, 4 minus 2, 2 and 6. Now let's divide 622 by 13. 13 4s are 52. We are left with 10, 102, which is not divisible by 13. Hence 622 is not divisible by 13. This complete number will not be divisible by 13. Similarly, you can take more examples and practice as well. This method is quite easy because the same method of divisibility we are applying for the 3 numbers, that is 7, 11 and 13, all of them. So you just have to practice with the technique and you will be comfortable with the divisibility test of 3 numbers simultaneously. Now we see the divisibility by 14. A number is divisible by 14 if it is divisible by 2 as well as 7. the number will be divisible by 2 if it is even, and it will be divisible by, and if it is divisible by 7 also, then the complete number will be divisible by 14. We have already discussed the divisibility test of 7. So I hope you will practice on your own with the divisibility by 14. Now why we have take 2 and 7, since we have already discussed, we have to choose the factors which are co-prime to each other. So 14's factor are 2 and 7, and these factors are co-prime to each other. So if the given number is divisible by these factors individually, then the number will be divisible by 14. Okay. Similarly, we can take the case of 15 as well. In the case of 15, we have to check whether the given number is divisible by 5 and 3 both as well. Okay. So divisibility by 15 is a number is divisible by 15 if it is divisible by both 3 and 5. Again, 3 and 5 here are the factors of 15 which are co-prime to each other. Let's see the next divisibility. Divisibility by 16. A number is divisible by 16 if the last 4 digits are divisible by 16. The number formed by the last 4 digits is divisible by 16. Okay, you can practice on your own. Similarly, divisibility by 24. A given number is divisible by 24 if it is divisible by 3 and 8. Further friends, 3 and 8 are the factors of 24 which are co-prime to each other. So if at all we have to check the number whether it is divisible by 24, we can individually go for the divisibility of 3 and 8. Similarly, divisibility by 40. A given number is divisible by 40 if it is divisible by both 5 and 8. So 5 and 8, again, these are the factors of 40 which are co-prime to each other. Similarly, we can check whether the given number is divisible by 65, maybe 72, maybe any other number. In case of 65, we have to check whether the given number is divisible by 13 and 5 both as well. Here 13 and 5, both of them are factors of 65 which are co-prime to each other. If we have to check whether the given number is divisible by 72 or not, in that case we have to find out the factors of 72 which are co-prime to each other. So 8 and 9 are the factors of 72 which are co-prime to each other. So 8, if the number is divisible by 8 and 9 both as well, then the given number will be divisible by 72. Now what's the divisibility test of 8? The last 3 digits must be divisible by 8. And what is the divisibility test of 9? That is the sum of the digits must be divisible by 9. So divisibility tests are quite simple. We just have to practice with them. They will definitely be useful for your entire career. Okay, we are getting good number of questions based on divisibility test in various entrance examinations. Maybe if you are going to appear for CAT, if you are going to appear for MAT, or if you are going to appear for any sort of Olympiad exams. We'll be discussing some problems of divisibility, like how MCQ questions can be solved if you are clear about the divisibility test. We'll be discussing in our coming sessions. As of now, I hope you must be cleared about all the divisibility tests we have discussed so far, and you can create your own divisibility test if you are clear the basic fundamentals of the divisibility. All the best, friends. Let's meet in the next session. Bye-bye.